Hello guys, welcome to IB 360. In this video we are going to study about the addition of two vectors from our IB syllabus. If you haven't watched our previous videos regarding vectors, you won't understand this video. So it's highly recommended that there is a playlist above you. Click that playlist, watch that videos, then come to this video. Your concepts will be cleared. So with that stated, let's just proceed further. So we are going to study today about the addition of two vectors, right? So that means suppose I have a vector. So suppose this is the vector. Suppose I call this vector as our a1 vector, okay? And I have suppose another vector. Suppose I have another vector in this direction. So okay, so that means I call this vector as a2 vector. Now, so what do you mean by addition of two vectors, right? So we'll be adding up these two vectors, right, and converting them into a single vector, right? So that means, see, the adding of two vectors actually follows the parallelogram law. Okay, so that means what does the law states, right? See that there are these two vectors, right? So that is, this is our vector number 1, that is a1 vector, and this is our vector number 2, that is a2 vector, right? So that means first of all what we need to do is that we have to construct a parallelogram with these two vectors, right? So that means, see, what I am doing is that I am creating a line parallel to a2 vector over this point A. Okay, I am creating a line parallel to our a2 vector, right? So I have created the line parallel to a2 vector, and this magnitude should be equal to how much? A2 vector, right? So that means the line's magnitude from here to here should be equal to our a2 vector. Okay, again we have to construct a parallel line to our a1 vector, right? So suppose this is our a1 vector. Okay, construct a parallel line from this point B. Okay, so at the tip of the vector a2, right? So that means construct a parallel line, you'll get this, right? So suppose they both meet at this point C, and suppose the initial point be O, right? So what were our vectors? See, this was our a1 vector and this was our a2 vector, right? So that means the parallelogram law states that the addition of these two vectors, okay, will be along the diagonal of the parallelogram. Okay, so that means over here A C B O is a parallelogram, right? Because see, the opposite sides are parallel to each other, that is AC is parallel to OB and OA is parallel to BC. So that means the parallelogram law states that when you will add the two vectors, this vector and this vector, the resultant would be along the diagonal of the parallelogram, right? So that means the resulting vector will be along the OC. So this will be the addition of the two vectors. So this will be our vector. Okay, just a second. So that means what does the parallelogram law say? That the addition of two vectors will be directed along the diagonal of the parallelogram. So diagonal along the parallelogram, right? So that means whenever you have two vectors, okay, suppose I have a vector in this manner and a vector in this manner. First of all, when you need to find the addition of these two vectors, okay, first of all what will we do? We'll just name this first of all. So suppose this as OA. Okay, the length of this a1 vector is OA. Similarly, the length of this OB a2 vector, suppose this vector is a2 vector, the length of this a2 vector is OB. Okay, so that means first of all what we need to do? First of all, again we'll need to construct a parallelogram, right? So again constructing a parallelogram. So this will be our parallelogram. Suppose name this point as point D, right? How to construct a parallelogram? Draw a side parallel to this OB vector equal to its magnitude. Again draw a side parallel to this AO vector equal to its magnitude, right? So that means this will be a parallelogram. Now, so that means over here we have the parallelogram as ADBO, right? So that means which is the diagonal of the parallelogram? OD is the diagonal, right? OD is the diagonal. So that means the diagonal of the parallelogram, that is OD, will be our resulting vector from adding up these two vectors, right? So this will be the vector. Okay, so whenever you get two vectors, we'll add them up with the help of our parallelogram law. Okay, so proceeding on to the second case, that is a special case. Okay, so suppose I have two vectors at 90 degrees to each other, that are at 90 degrees to each other, right? So suppose I have this vector, so suppose this vector is our a1 vector. Okay, and I have this vector again, so suppose this vector is our a2 vector, right? Such that the angle between these two vectors are 90 degree, right? Again, how can we add this up to? First of all, construct a parallelogram. Very good. So that means first of all, draw a line that is equal to our a2 vector's magnitude, right? So this will be the line, right? So over here, this will be the line parallel to our a2 vector, equal to its magnitude, right? Again, we have to draw a line which is equal to our a1's vector's magnitude and parallel to it, right? So that means this will be the line again. So this will be the line, not the dotted part, the this broad line. Okay, so that means over here we have formed the parallelogram, right? So that means suppose OA vector is actually a1 vector and OB vector is a2 vector, right? And suppose they meet the parallelogram as the other side as D. Okay, so that means we have formed the parallelogram, right? So that means ADBO is our parallelogram, right? Very good. So that means what is this feature of this parallelogram? Why is called a parallelogram? Why? Because the opposite sides are parallel, right? AD is parallel to OB and is equal to its magnitude, right? We have constructed in such a way. Okay, so that means AD is parallel to OB and AO, opposite sides are parallel, right? AO is parallel to DB, so that's why it is a parallelogram, right? Now the vectors were, now concentrate on the vectors. See, this was our vector a1 vector and this was our a2 vector, right? So what does the parallelogram law say? That the addition of these two vectors will be along the parallelogram, along the diagonal of the parallelogram. Okay, addition of these two vectors will be along the diagonal of the parallelogram. Now what is the diagonal? OD is the diagonal, right? So that means the addition of these two vectors will be this vector along the diagonal of the parallelogram, right? So this will be our net vector. So this is our a3 vector, right? So that means, just let me write this in black. So this will be our a3 vector. So that means a3 vector is produced due to the addition of a1 vector and a2 vector, right? So that means when we'll add up a1 vector and a2 vector, we'll get a3 vector. So over here we have a special property, which is what? Which is that the a3 vector magnitude, right? Magnitude of the a3 vector, see, magnitude of a vector is represented by these two signs, one at the front and the other at the bottom. Okay, at the other side, right? So that means the magnitude of this vector a3 vector would be equal to the square root of magnitude of a1 vector whole square plus a2 vector whole square, right? So how is this coming? See, over here, as this angle is 90 degree, right, I can also tell that this angle will be also 90 degree, right? So now what happens is that, see, so this was our, see, this was our what? This was our a2 vector, right? So that means the magnitude of OB is what? Magnitude of OB is mod of a2 vector. That is the magnitude of the a2 vector, right? Again, the magnitude of dB, how much is the magnitude of dB? dB is so constructed that its magnitude is equal to OA, right? We discussed in the previous slide. So that means magnitude of dB would be magnitude of a1 vector, right? Magnitude of a1 vectors, just let me remove the clutter over here. So that means, can I write that since over here is OBD is what? A right angle triangle. Very good, it's a right angle triangle, right? So that means on a right angle triangle, so I can write that OB square plus BD square This is equal to the hypotenuse square, that is OD square. Can I write this? Yeah, I can write this. And what is OD? See, OD is what? Yeah, very good. The magnitude of the A3 vector, which spans from the tip of the tail to the end of the tail, right? So that means I can write there the magnitude of our A3 vector whole squared is equal to, just let me just change the color, whole square will be equal to how much? OB square. OB is what? The magnitude of A2 vector. We discussed magnitude of A2 vector whole square plus magnitude of magnitude of my mistake. What is BD? Magnitude of A1, right? Magnitude of A1 vector whole square. So right, so that means over here can I write that the magnitude of our A3 vector, the magnitude of the A3 vector, mind it's only magnitude, it's not direction, okay? The magnitude of the A3 vector will be equal to how much? Will be equal to us square root of A1 vector, magnitude of A1 vector whole squared plus magnitude of A2 vector whole squared. Okay, so it's very easy. Actually, we'll be demonstrating this with the help of examples in the next slides. Okay, so that means we found the magnitude of the resulting vector, that is our A3 vector, right? But vectors both need magnitude and direction, right? So that means we need to find out the direction of the vector, right? So suppose this vector is making an angle theta. A3 vector is making an angle theta with the positive x-axis, right? So this is the angle, right? It's making with the positive x-axis. So if I find the angle theta, I can write that this angle theta is the direction of the vector from the positive x-axis, right? So that means if I just find the angle theta, will be done, right? So that means now consider this triangle, right? The triangle ODB. In this triangle, can I say that tan theta will be what? Tan theta would be equal to how much? See, it will be equal to height by base, right? Height is what? dB, right? From the figure. And base is what? Base is OB, right? Tan theta, right? We are just finding tan theta, right? So that means, see, BD is what? BD is so constructed that is magnitude is equal to OA vector, right? So what is OA vector? A1 vector, right? So dB will be equal to the magnitude of how much? A1 vector divided by, so what is the magnitude of OB vector? So just let me write this. So it will be the magnitude of A1 vector, right? Now what is the magnitude of the OB vector? OB vector is what? A2 vector, right? OB vector is A2 vector. So the magnitude of OB vector will be how much? Mod of, that is the magnitude of A2 vector. So that means this will be equal to the magnitude of A2 vector. A2 vector, right? So that means we have found the tan theta. So that means I can write that the vector, the resulting vector is at an angle theta is equal to tan inverse A1 vector divided by A2 vector, magnitude of A1 vector divided by magnitude of A2 vector away from the positive x-axis, right? I can easily write that. Okay, now, so I hope you got the concept of adding of two vectors using when the angle between them are 90 degree. Okay, so suppose I have two vectors. Suppose the first vector is your A1 vector, right? So A1 vector is given to be how much? 3 Newton towards the north. 3 Newton towards the north. Again, we have another vector, that is our A2 vector. A2 vector is given to be how much? A2 vector is given to be your 4 Newtons towards the east. 4 Newton towards the east. So that means A1 vector will be right towards the north. So that means arrowhead will be pointing towards the north in this direction. So that means this vector will be 3 Newton. Right, and A2 vector is pointing towards the east, so that means the arrowhead is pointing towards the east. So that means this A2 will be this vector, right? So this will be, it will be 4 Newton. So we have to find the addition of A1 vector plus A2 vector. So how can you find the addition of A1 vector and A2 vector? Again, draw the parallelogram, right? So the addition of these two vectors will be along the diagonal of the parallelogram, right? So this is our parallelogram. So OABC is our parallelogram. What is the diagonal of the parallelogram? From O to B, right? So that means this will be our, so this will be our resulting vector, right? So suppose this vector is our a3 vector. So that means I can tell you that a3 vector is the produced due to addition of this a1 vector plus your a2 vector, right? So we have discussed this, right? So now we need to find out the magnitude and direction of the a3 vector, right? So that means for magnitude I can write that the magnitude of a3 vector, see the angle between 3 Newton force and 4 Newton, they see one is acting along the north and the other is acting towards the east. So that means the angle between these two vectors will be how much? 90 degree. Because the angle between north and east is how much? 90 degree, right? So that means I can apply the formula for the special case. First of all, you have to be clear that the angle between the two vectors must be 90 degree. Okay, don't miss this mistake. Okay, so that means the magnitude of our a3 vector will be equal to how much? This will be equal to the magnitude of a1 vector whole squared plus the magnitude of a2 vector whole squared, right? So see, for this vector, what is the magnitude of a1 vector? 3 Newton, right? Just taking the magnitude, rejecting the direction. And magnitude of a2 vector is how much? 4 Newton, right? Taking the magnitude, rejecting the direction, right? So that means I can write that a3 vector will be equal to how much? Square root of a1 squared. So that means 3 Newton whole squared plus 4 Newton whole squared. So this will be equal to your 5 Newton. So the magnitude of our a3 vector is 5 Newton, right? Now we have to find the direction of our a3 vector. Okay, so that means again consider this triangle. This is theta, right? So from this triangle I can write that tan theta is how much? Tan theta is BC by OC, right? You can use the formula also, but I'm doing the way. Okay, so what is BC? BC is so constructed that its magnitude is equal to OA vector, that is 3 Newton, right? 3 divided by, now what is OC? OC is the magnitude of 4 Newton vector, right? So that means this will be equal to 4. So that means our tan theta comes out to be 3 by 4. So that means from here I can write that the angle between these two vectors is how much? Tan inverse of 3 by 4. The angle between the original vector, that is the a3 vector, and the x-axis, right? So that means theta is the angle between the sum of two vectors and the x-axis, right? So that means I can write from here that the net a3 vector will be how much? So this will be your 5 Newton, magnitude is 5 Newton, and what is the direction, right? Theta degree above the positive x-axis, right? So that means tan inverse 3 by 4, tan inverse 3 by 4 away from x-axis, right? So why? This is the x-axis and the vector is at an angle theta from the x-axis, right? So what is the angle? Tan inverse 3 by 4 away from the x-axis, right? So you can write this, or you can also skip this part and write tan inverse 3 by 4. Okay, we'll understand. Okay, so I hope you got the example. So for the second case, I'm just proceeding on. So suppose I have a vector, that is your a1 vector is equal to your 5 Newton acting at an angle of 120 degree. So whenever you'll be given an angle from now on, it is from the positive x-axis, right? So now, and I have a vector a2 vector that is of magnitude 6 Newton acting at an angle how much? Acting at an angle of 60 degree. Okay, so that means 60 degree means away from the positive x-axis. So that means see, construct a1 and a2. So see, this is our x-axis, right? Okay, so this is our positive x-axis plus x. So what is the angle? 120 degree away from the positive x-axis, right? So go away 120 degrees in this direction. So that means this will be our a1 vector. So this will be our a1 vector, and the magnitude is how much? 5 Newton, right? 5 Newton. Okay, again construct this vector. A2 vector is how much? 6 Newton acting at an angle 60 degree, right? So that means 60 degree from the positive x-axis. So that means go at an angle of 60 degrees. So go 60 degree over here. So that means over here, this will be our a2 vector, right? What is the magnitude of our a2 vector? 6 Newton, right? So that means this will be 6 Newton. So this angle is given to be 30. My bad, it's given to be 60. Just a second. So this angle is given to be 60 degree, and this angle is given to be how much? 120 degree. So that means, can I say that the angle now between between the a1 vector and the a2 vector is 60 degree, right? So that means the angle between these two vectors will be now what? 60 degree. Why? Because this is 60 and this is, the total is 120. So I want this angle, right? The angle between these two vectors. So this will be how much? 60 degree. Okay, and this was our 5 Newton case, and this was our 6 Newton case, right? Now, are they at an angle of 90 degree to each other? No, they are not at 90 degree. So they are not at 90 degree. Okay, first of all you have to check. Okay, so when they are not at 90 degrees, so we can not apply the special formula, right? So over here, if we want to find the resulting vectors, that is a1 vector plus a2 vector. Okay, again what will we do? We'll just construct a parallelogram. See, over here I'm constructing a parallelogram. So this side will be parallel to your 6 Newton vector and be equal to its magnitude. Okay, so this is the first side, and this is the, and this side, other side will be parallel to 5 Newton vector, right? So that means this will be the parallel to the 5 Newton vector and equal to its magnitude, right? So this becomes our second side. Now name the parallelogram. A, B, C, D is our parallelogram, right? AB vector is our 5 Newton vector and AD vector is our 6 Newton vector. Okay, so that means which will be the addition of these two vectors? The resultant vector by parallelogram will be, parallelogram law would be along the diagonal of the parallelogram. So from A to C, from A to C will be our resulting vector. So let's just call this as A3 vector. A3 vector. So that means the sum of these two vectors, that is A1 vector plus A2 vector, will be directed along the parallelogram, along the diagonal of the parallelogram. That will be our A3 vector. So we cannot find this magnitude. Actually we can find, but this is beyond our scope for IBDP syllabus. Okay, so I hope you got this concept and like this video. We'll be coming up with more and more examples on addition of vectors, more and more previous year questions on IBDP syllabus on vectors. So do subscribe, hit the bell icon and stay safe. Thank you for watching our videos.